Assalamu alaikum students. Now today we'll start with two new quantities, that is speed and velocity. Why are we studying these two quantities? In our last section we talked about distance and displacement. Why do we study them? Because they talk about the position of the object. Now let's they as you know they talk about the position of the object. They talk about how much distance an object covers in a specific period of time. Now these two quantities tell us about the rate of change of position. That means the rate at which the object is moving. You often heard of things like I walk faster than you, or runs faster than Sham. What do I mean when I say somebody moves fast or somebody runs slower? So fast or slow basically describes the speed of that person, means the rate at which a person is moving, the rate at which the position is changing with time. So here we will talk about these two quantities, speed and velocity, which actually talk about the rate of change of position with time. So let's start with talk about speed. What is speed? It's the rate at which an object covers distance. So speed, as I mentioned earlier in the previous lecture also, that it's a scalar quantity. That means in order to define speed, only magnitude is enough. If I say that there's a boy, say, who runs at a speed of 2 kilometers, say, per hour, so I don't really need to mention the direction in which he runs. Okay, just the magnitude is enough to describe speed. So speed will tell us how fast or slow an object moves. So how do we mathematically calculate speed? Okay, now as we know that speed is the rate at which an object covers distance, right? So speed is the distance traveled divided by time taken. Distance is also known as path length. So speed is the total distance covered, or the total path length divided by the total time taken, divided by time taken. So speed is a scalar quantity. Okay, it's dependent on scalar quantity distance. Okay, speed is dependent on distance. So what is the SI unit of speed now? As speed is equal to distance divided by time, or path length divided by time. So what is the unit of path length? Distance, and that is meter, divided by what is the unit of time? That is second. So meter divided by second, you can say meter per second. This is the unit of speed, or sometimes it may be kilometer per hour. Okay, this is all about speed. Now let's move to velocity. What is velocity? It's again the rate at which an object changes its position, same as speed. Now velocity is a vector quantity. It's nothing but speed with direction. Since it's a vector quantity, so it's dependent on vector quantity, that is displacement. So velocity is equal to displacement divided by time taken. One more thing, you can also see velocity as speed with direction, because it's similar to speed, but there is a direction involved in velocity. So we can say velocity is speed with direction. So the way there is a difference between distance and displacement, similarly there exists a difference between speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. Both has the unit meter per second. Speed is given by total distance covered divided by time. Velocity is given by total displacement covered divided by time. Now let's take an example to understand speed and velocity clearly. Let's take the same example of a small boy. Let's take the same example of a small boy to understand speed and velocity. Say the boy is at home, is at rest. Okay, let's suppose the distance between his home and McDonald's is say 2 kilometers. Now this boy starts cycling from home, reaches McDonald's, and say it takes U-turns and comes back. Okay, and comes back to his house. Now we'll try to calculate speed in this case. What could be the speed in this case. Speed is nothing but distance divided by time. So what is the distance traveled? That is 2 kilometer while going from house to McDonald's. Then it comes back. Again it travels 2 kilometer, right? So total distance traveled is 2 plus 2, that is 4. Total distance is 4 kilometer. Now he say he takes 1 hour in going from house to McDonald's, and it takes another 1 hour from in coming back. So again it time will be 2 hours. So distance is 4 kilometer, time is 2 hours. 4 divided by 2, and you will get 2 kilometer per hour. So speed comes out to be 2 kilometer per hour. Okay, now let's look at the same thing but in terms of distance time graph. Okay, now so far for the same scenario we will plot distance time graph. But what is distance time graph? Is the graph where you plot distance along y-axis and time along x-axis. Okay, it's conventionally given by the scientists that time should be always plotted on x-axis and distance should always be plotted on y-axis, because x-axis is the independent axis, and as we know, time is independent. Time doesn't depend on distance, and y-axis is a dependent axis and distance is also a dependent axis, dependent quantity. That is why distance is plotted on y-axis. Okay, now what is the graph actually depicting? It actually tells us how the distance varies with time. Now in this case, we see that the distance covered by boy increases as the time increases. When we plot the graph, distance, we will get this type of graph, and distance is increasing as time increases. Okay, now speed came out to be 2 kilometer per hour, right? So in 1 hour, this boy was gradually taking some distance, and finally it covers 2 kilometers in 1 hour. So in this case, if we plot distance time graph, it comes out like this, and that is the distance increases with time. So in this case, slope of this line gives us the speed of object, because when the distance increases linearly with time, that means as time increases, distance also increases proportionally. In that case, we will get the graph like this. That means when say time is 1 seconds, distance covered will be 1 meter. Time is 2 seconds, distance covered will be 2 meters, another 1 meter. Okay, so this kind of line we get when equal distances is covered in equal intervals of time. So in this graph tells us how much distance is covered with respect to time. So slope of this line gives us the speed of an object. Now how do you calculate the speed of this line? Slope of the line is given by tan theta. Okay, look here, it's a kind of a right angular triangle, and we will try to find the slope of the line. We will try to find the speed of the body, and speed is given by the slope of this line, and slope of this line is equal to the tan theta. It's nothing but from this triangle you can say that slope tan theta is equal to perpendicular divided by base. So here perpendicular is AB and base is OB. So you can say tan theta is AB divided by OB. So let's look at the same thing from graphically. In this case, you will see that boy covers distance of 4 kilometers in 4 hours. So AB is 4, OB is 4, and 4 divided by 4, you will get 1 kilometer per hour. This is the speed of the body here in this example. So you understood in this graph. So you understood what is speed. Speed is nothing but the rate of change of position. So if we want to derive speed, you need to plot the graph, distance time graph, and slope of the graph gives you the speed of the body. Thank you.